Hey everybody, my name is Milecia, and today I'll be talking to you about secure authentication in your web apps. So a little background about me. Right now I'm a developer advocate at Iterative.ai, where I work on the DVC open source project. And it's probably as far away from secure authentication as I could be, but it's a tool that's used for machine learning projects to make it easier to go through different experiments, and I've been using this on my air guitar project. So hopefully soon I'll be able to read brain signals and make sense of those. But before I was doing this, I've worked in front-end development, back-end development, DevOps. I did some work on the Mozilla VPN. So if it's tech related, I probably have dabbled in it a little bit at least. And throughout this presentation, if you want to ask me any questions, you can feel free to reach out to me on Twitter at FlippedCoding. But with all of that being said, let's just jump into some secure authentication stuff. So what makes authentication secure in the first place? There's a lot of different things that you can implement or different tools you can take advantage of. But let's start with some of the, top things that people do to secure their apps. I'm sure a lot of you are familiar with multi-factor authentication, so you make your users verify their identity on another device. So they'll log in and you'll require them to send some kind of code to an email address or a phone or some kind of third-party app, and they'll also verify that they're the ones trying to log in through that. And what this does, it just helps give another avenue for users to protect themselves against attacks. So if somebody has hijacked their account information and they try to log in, they won't be able to access anything because they don't have access to that email address or that phone number or whatever other way that we have implemented with multi-factor auth. And then this is something that's always been fun with cell phones, or iPhones in particular, is when you delay the time that a user has to log in again. So you can limit how many attempts a user has to log in, which a lot of apps do that, where maybe you have 3 attempts to log in before your account gets frozen and you have to reset your password anyways. Or maybe you make them wait a certain amount of time before they can try again, like I was mentioning with the iPhone example. But what this does, it just slows down any attackers that are trying to do things like maybe a brute force attack, where they have a username or an email address and they're just basically spamming passwords, trying to figure out what works. So when we limit the number of login attempts, or we add that delay to the next login attempt, that just stretches out the amount of time it takes for these attacks to happen. And by increasing that time or completely shutting down the ability to attempt, we're making sure that attackers aren't able to just brute force into your account. And then this is something that is a little bit tricky, because as developers we want to find that good balance between giving users information that is useful to them. So if they are logging in with the right username but the password doesn't match what's with that account, it's really tempting to tell them, hey, you're using the wrong password. But when we're trying to prevent attacks, it's more useful to give some generic message like login invalid or failed attempt, or something that doesn't give away what is specifically wrong with this authentication. So using the same messaging for all failed logins is just a good way to get around that kind of weird social engineering aspect of attacks, we don't want to give them any information about what they could be doing better to hack our apps. So making sure that we keep that message consistent, that is one of the ways we can shut down that avenue. And using server-side session management to generate new session IDs after a user logs in is another great way to handle this, where users don't really have to do anything. They don't have to interface with anything. They don't have to wait. The only thing is that when they log in on a new device or in a new browser, it invalidates the other session that they have. So this is something that's really useful with like bank apps or in the healthcare industry or places with super sensitive data that you just don't want anybody else to have access to. So the only downside, which really isn't a downside even for a user, is that you just have to log in again. But at this point, I'm sure we've all forgotten our passwords enough that logging in again isn't that big of a problem. And this final point is one of my favorites because I see a lot of apps that just don't do this. But check for weak passwords. So when you're letting a user set up an account or you're letting them reset a password, do that extra form validation where you make sure that they're using some combination of numbers and letters, maybe throw in some symbols and give it a minimum length, you know, the little things that really, really will help keep your app secure. Because when you put those kind of limits around a password, it makes users create something more secure anyways. So you won't have the app that got hacked because the password was password. That's really what this check for weak passwords prevents, is those generic things getting in and somebody's account gets hacked and then it's a multi-million-dollar problem because now you have to deal with cleaning up all of that data that was leaked. So let's not be that app and go ahead and take advantage of some of these things. If possible, all of them aren't a bad idea, but I understand there's a balance between keeping users happy and having this secure authentication. So the next thing we can look at is actually securing the server. A lot of times when users interact with an app, they are making API requests. And that's where the authorization grant type comes in. So this is usually the flow that happens when we're making requests to an API. We have an authorization code that's generated when the user logs in, and we exchange that on the server for an access token, which lets us get data and make requests to whatever APIs we need to. And the way that this works is the user logs in, we get some kind of authorization code, the user is redirected back to the app, and the auth code is taken from sometimes the URL, and it's used to get an access token. So that's the general authorization grant type flow, where we get this authorization code after the user logs in, and we at some point exchange that code for a token. But there's a little bit of a problem there. There is a chance that the auth code could be intercepted. So if an auth code is intercepted, there's nothing to tell the API server or the authentication server that this isn't the same user that made this original request. If the auth code is intercepted by some outside party, they can exchange that for an access token and use that token to update account information, to get a bunch of personal data from a certain account. they can use that auth code to get the access token to do anything, basically. And we definitely want to protect against that, because part of the problem with the auth code is when we're exchanging it for an access token, there's nothing there to tell us that this is the same user that made this request in the first place. That is where Pixi comes in to fill in that gap for this authorization workflow. So with Pixi, we're taking advantage of the OpenID Connect protocol, and basically this just adds an extra layer of authentication on top of that authorization code so that we know the user that initiated the request is the same user that we're sending the access token to. And that's what Pixi gives us. This is just an addition to the authorization flow. So instead of just logging in and getting an access token, first we generate a secret code verifier that we use to make a code challenge. And when these have been generated, so basically those get generated whenever a user clicks the login button. And when they do click the login button, we generate that, we store it, and we redirect the user to the authorization server to log in. So this is where they'll put in their username and password, and then we redirect back to the client to verify that we have that same code challenge. So this is where that like OIDC protocol comes in, and it's how we determine that this is the exact same user and the auth code hasn't been hijacked. We're good to go because we can validate that the challenge we're returning back to the client is the same as the challenge that was generated by the client. So once we've made that redirect and we verified that challenge, that code challenge, then we exchange the authorization code for an access token. But Pixi basically makes it so when a user makes a request, we generate some random string. That string, well, the challenge is that string. We send it to the auth server. After they log in, we send that challenge back. And if it is decoded by that code verifier, we know this is the same user. OpenID Connect is happy. We've authorized the thing twice, so we really know this is the same user. And then we can finally exchange that authorization code for an access token. So now I want to get into the fun part of a live demo that was working exactly when I hit the record button. So it should still be working, but a little quick background on this before I switch over. Well, I can switch over and give you the background. But at first I was thinking about going through and implementing Pixi from scratch, like making the whole authorization server, an API server, handling some client stuff. But that's probably not something you're gonna do just in day-to-day work. Most likely you'll have an app and you'll need to add some kind of secure authentication to it, and you'll take a look at the tools that are out there. So instead of spinning up this really complicated, super technical thing from scratch, I'm actually going to show you how Auth0 implements Pixi and how it's another tool that you can use to add secure authentication to your apps without having to create everything from scratch. Because honestly, when I was trying to make this demo, there's so many little moving parts that you have to think about if you're trying to spin this up from scratch. That's kind of the reason there are companies around that do this. It's a hard problem. So You don't have to feel like you're cheating by using a package, because at first I did, and that's just not true. It's just a problem that's already been solved, so you don't need to reinvent the wheel. And that's why we're not gonna do that today. So I have here the Auth0 quick start example. So if you go to their website and make an account and get through the docs and all that good stuff, you'll be able to download a version of this code that's basically the exact same thing as I have here, or you can clone it off of my own GitHub repo. So either way, it'll give you the same thing. But before we get too far, I do want to show you what this app looks like when it's running. So this isn't too unfamiliar. You have a dashboard, it's showing some stuff, and you have this login button. So that's the app we're working with. We're going to log in and make a request to an external API. So we're going to have some Pixi flow in here because we have to exchange our auth code for an access token, but thankfully Auth0 handles all of the Pixi stuff in the background for us. So I'm going to switch back over to VS Code now. And to start with, let's take a look here in our views. So we have this home, which is what you see, but we also have this external API. And if you remember back when we took a look at the app, there was not a route or any text anywhere for this external API component. And the reason for that is because you have to be logged in and authenticated in order to see it. So this is the same as if you were trying to log into your bank app, but when you're on the website, you won't see any of your dashboard information. So what we're using here is the Auth0 React SDK, and it comes with a bunch of stuff baked in for us. So for example, we have this with authentication required component, and this is a higher order component that will pass our, our external API component into. And you see down here, we export the external API wrapped in this higher order component. And basically what this does, you can kind of see it in the little pop-up here, but pretty much it makes sure that no one can see this route unless they're logged in. So Auth0 keeps track of the login state, it keeps track of the authentication, it keeps track of the access token. It does all of that for you when you use this higher order component on any components that you need protected. So if I take a look here in index, you'll notice that our entire app is wrapped in this Auth0 provider. And this is where you'll put in your configs that you have for your Auth0 account. And that's how you'll be able to configure things like approved callback URLs or approved login and log out URLs. This is where you'll set up users to have different roles and permissions. This is where you can set up acceptable users. So the Auth0 provider is how we get access to all of the other Auth0 functionality in the React SDK, because now we have our account linked with this particular app. So that's pretty much what's happening on the front end. We're using the Auth0 provider to protect all of the routes that need authentication, like our external API, because we have to have that access token in order to call the API. So if I come back out of the client side and we take a look at our API server here, so you'll see that we have some auth configs we set up, and down here is where it gets interesting. So we have this get API external endpoint, and we'll be checking the access token. And if the access token is valid, we'll send this message. But of course, this could be any other type of functionality. You could send back revenue data or test results or whatever it is you're trying to protect. But the point is here, whenever we send a request, we'll check the JWT or the JSON Web Token. And what we're looking for is to make sure that this token is valid, that it has the right user information, and that it hasn't expired. So all of that happens in this check JWT function, and all of this comes from this package here. So we're just validating a JWT and making sure that it is correct for our application. So with all that being said, let's actually take a look at how this works. I'm going to switch back over to the browser, and I'll walk you through which steps of Pixi are happening as we go. So I'm clicking this login button. That's going to go ahead and generate our code challenge, which is actually, if I can get to the end here. So you see we have the code challenge in the URL right here. So when I clicked that login button, all of that got generated for us. So now that we have our code challenge, all of this other stuff has been generated for us. We have the redirect URL. Auth0 did all of this automatically. So when I go to sign in, just using one of my Google accounts, it redirects me back to the client, and it's validating that code challenge you saw in the URL with what we had stored on the client side. So when we clicked login, we generated that code challenge, it sent it, and when we redirected back, it validated that code challenge against what we had before. So that's kind of how Auth0 implements the OIDC protocol, so that we know we have the right user for every step of the way. And now that we're logged in, we've exchanged that authorization code for an access token, and you see the external API route. We have our token, so when I ping this API, it validates the token, makes sure that it has all the right information, and we get our message. So that is the reason why we use packages or SDKs and services like Auth0, because as simple as it looks to click through this flow, and maybe even in the code that we went through, when you're trying to spin that up from scratch, it is not easy. So that's why I decided to show this tool, because it is something practical. You can take this to work and add the Auth0 SDK to any React app that you're working with right now. I've even used it on some of my personal apps just because it's that easy to work with. And even when it's not, it's so much easier than if you had to do all of this yourself. So save the time like I did and just use the service. It's totally fine. But with that being said, I'm gonna go ahead and get ready to close out. So let me switch back to my presentation. And we have implemented Pixi. So I want to wrap up with just a few little tidbits that I hope you take away. So one thing is that a lot of times security doesn't come up until there's a problem with security. But if you have the opportunity, start every project you have with security in mind, even if it's something as simple as just setting up the login and log out You don't have to worry about access tokens yet, but just get something in place that you can add on to, because security is always a risk. You have to make sure that you're accounting for that at different phases in your development. And then don't be afraid to use the services that are already out here for you. You don't have to write things from scratch. It doesn't make you a bad developer. It doesn't make you lazy. It makes you smart. There are teams that spend their entire day working on this stuff. It's okay to use it. And then if you're already using the authorization grant type, Pixi is just one of the ways you can add an extra layer of security. So you don't have to change a whole lot that you're already doing. It's just another layer on top of it, just like if you were adding multi-factor authentication or anything else. Pixi is just an added layer of security that the user doesn't necessarily have to worry about. So I hope that this talk was useful and you were able to take something actionable away from it. And again, if you have any questions, feel free to reach out to me on Twitter at FlippedCoding. Thank you.